Hey everybody, so today we're going to talk about how we take a glucose molecule and we turn it into a pyruvate. And so basically what's going to happen is I'm going to tell the story, and it might seem confusing with all these letters and whatnot, but it will be explained later on. So first I'm going to tell the story. Just listen up, you can always rewind and listen to it again, and then after I tell the story, then I'm going to actually explain what is going on in the story and how it relates to glycolysis. Okay, so pretend I'm a glucose molecule, just coming in, and then I come into my little house, which is a cell. I come in through the glucose transporter. If in a regular cell, it'll be GLUT1 or GLUT2. If I'm in the liver, it'll be a GLUT4. So I come in, assuming it's just a cell, and then I open a door, which is a hexagonal door, and then it takes energy for me to come in and open the door. And then I come in, and then I feel really isolated because I'm the only glucose there. So then I'm glucose 6-phosphate, and since I'm so isolated, I lose a carbon, and then I become fructose 6-phosphate. And now feeling this isolation and depression, I want something to cheer me up. So someone comes and kindly phosphorylates me using phosphofructose kinase 1, and they use energy to do so, and they make fructose 1,6 bisphosphate, and it takes 1 to 6 minutes to make that fruit toast. Okay? And now that I have a little bit of energy, I want to buy new shoes, right? I want to go out, so I go to Aldo to get new shoes. So there's 2 pairs of shoes that I really love, but one, actually when I bring it home, I think it makes me look fat. So I exchange it using triose phosphate isomerase, because I feel kind of isolated when I wear it and I look fat, into glyceraldehyde 3-phosphate. Now I really, really love glyceraldehyde 3-phosphate, so I actually get 2 of them. And after all this going to the store and coming back, I feel really dehydrated. So I basically now I want to make sure all this work pays off. And basically what happens is I'm glistening in sweat, and I take 1 to 3 minutes to cool down and look like Paul George. Now that I'm glistening and looking like Paul George, someone kindly comes to Paul George and uses energy to get him 3rd in the NBA. So Paul George is now 3rd in the NBA because someone kindly came and made him so. Now that I'm 3rd in the NBA, I wanna, why am I 3rd? Why can't I be 2nd and 1st? So I go through a mutation and I become 2nd in the NBA. Now, after all this work, basically, I want to cool off. Now, I sweat, so I release water, and now I'm also thirsty, so I drink some Pepsi, and he knows how good Pepsi tastes. Now that I had my Pepsi, now I have energy back, so I have energy, so I gain energy. And now that I have that energy, I kindly eat some pie. Now I'm happy. So now I'm going to go back and explain what just happened in the story. Okay, so now that we heard that fascinating story, we're gonna talk about what actually goes on and what was going on in the story. So first of all, I'm a glucose molecule. I come into the cell using a glucose transporter. I have 2 enzymes here. Glucose can be phosphorylated using hexokinase or glucokinase. In most cases, it is phosphorylated using hexokinase unless you're in the liver or in the pancreatic beta cells. Now, what glucokinase is an isomer of the hexokinase, so they have the same function, but they do not look the same. Okay, so this phosphorylation basically adds a phosphate group, so you're basically inputting energy. Okay, that's why you have the ATP and the ADP coming out. So now that you have this glucose 6-phosphate, now this glucose isomerase comes in, and then it takes out a carbon, and now this is a 5-carbon molecule. Fructose is a 5-carbon molecule. That's why a good way to remember it is fruit toast. So now you have fructose 6-phosphate. Now a molecule comes in called phosphofructokinase 1. Someone kindly gives me fructose. So by phosphorylating. So basically this is another phosphorylation. So you're putting another phosphate group. So now you have two remember that you have two. The first one was here, so now you have a second one. So you have two phosphate groups on this glucose molecule, which was a glucose molecule. So now remember that you also have sped 2 ATPs. Now this is also called your rate limiting step in glycolysis. So that is important to remember. The number of enzymes of phosphofructokinase 1 limits how fast glycolysis runs. So after that happens, you have fructo 1,6-bisphosphate. So I said that making this takes 1 to 6 minutes. I mean, it really doesn't. Glycolysis is really fast, but you can use that to remember 1,6. Now that you have fructo 1,6-bisphosphate, here there's two ways this pathway can go. So either you make DHAP, which is dihydroxyacetone phosphate, using the same enzyme to make glyceraldehyde 3-phosphate. Now, glyceraldehyde 3-phosphate is the molecule in glycolysis that continues on. So dihydroxyacetone phosphate is either metabolized to form fat, so a triglyceride, or it's put back into the cycle using triose phosphate isomerase. Okay, so and I like to think about it, if it's coming back, it used to be isolated and now it's coming back. Okay, so isomerase, that's one easy way you can remember it. So now we have glyceraldehyde 3-phosphate. So now this is a very important step. This is the step where it changes. So you know how you see, well, the energy expenditure. So you know how you see you're using energy? Well, now all that energy use is going to pay off. So this step happens twice in glycolysis. That's really important to remember. It happens twice. So it happens twice and you form everything now on, you have two molecules of. So you have two molecules of 1,3-bisphosphoglycerate. So I said how, now I'm using, when you see PG, that basically means Paul George in my story. If you don't know, he's a basketball player. So 1,3-bisphosphoglycerate. So you take 1 to 3 minutes to cool down. So you can remember 1,3. And then PG, you can remember phosphoglycerate by remembering Paul George. So now, whenever I have a kinase, I think about kindly either putting on or taking off a phosphate group. So here, you're taking off a phosphate group. So Paul George kindly takes off a phosphate group off of himself. So you form an ATP. Now that happens, you have 3 phosphoglycerate. So now my analogy was, now that happened, he has more energy, so now he's third in the NBA. Now he becomes second in the NBA, so 2 phosphoglycerate, and that happens using phosphoglycerate mutase. Now that you have 2 phosphoglycerate, you form phosphoenol pyruvate using an enolase. Now this E stands for enol, so that's one easy way you can remember it. And one thing you do have to remember is H2O is released, so something you can remember is using the story. Remember that Paul George is tired now that he's second in the NBA, so he sweats, releases a little bit of water. Now, remember my Pepsi analogy. So I call this Pepsi, so phosphoenol pyruvate. Now he wants dessert, Paul George, so he kindly takes off another phosphate, pretend he's taking off his ball shoes to chill. So now he forms pyruvate, he eats pie, and he's ready to move on to the TCA cycle by forming acetyl-CoA. And one important thing to remember from this entire process is that the net molecules made is 2 ATP and 2 NADH. It's really easy to forget that here the payoff is times 2, so that's why you have a net of 2 ATP. Okay, so Thank you for watching. That is glycolysis.